Good day, I am Teacher Blendel and today we are going to discuss the foundation of geometry. The objectives of this video are represent point, line, and plane using concrete and pictorial models, and illustrate subsets of a line. In this video, we will discuss undefined terms, defined terms, theorems and postulates, and measuring segments. Let's begin with undefined terms. Under the undefined terms are the point, line, and plane. Point. A point is an indication of a specific location in space. It has no length, width, nor thickness and can be represented by a dot. For example, a star can be a representation of a point since it suggests a particular location in space. Another examples are the tip of a pencil and sesame seeds. Line. A line is a set of points that extends endlessly in opposite directions. It has infinite length but has no thickness and width. For example, a line may be represented by any object resembling a straight line like a meter stick or a tightrope. Another examples are the edge of a board because it has length but has no width and thickness. Plane. A plane is a two-dimensional figure that has length and width but no thickness. For example, it can be represented by a flat surface and concrete objects like the surface of book. Another examples are a wall or a chalkboard. Naming undefined terms. A point can be named by a capital letter. Point A, point B, and point C. A line is represented by a straight line with arrowheads on both ends. It can be named using a lowercase script letter or by using two capital letters that represent 2 points in the line. A plane is named using a single script capital letter or by 3 distinct points on the plane that do not lie on the same line in the specific order. Let's have an example. Number 1. Name all the distinct points, lines, and planes in the figure on the right. Number 2. How many lines on the same plane could be drawn through point O? Name them. Number 3. Name 3 points that could determine a plane. Number 4. What are the planes that contain point E? Solution. Number 1. Points. Points H, O, N, E, S, T, and Y. Line. TE or line ET. Plane. Plane HON in any order. Number 2. 3 lines. Line OH, line ON, and line OE. Number 3. Points H, O, N, and point Y, T, E. Number 4. Plane HON and plane ETY. Defined terms. Now that the 3 undefined terms were described and discussed, other geometric terms can now be defined. Defined terms. Collinear points are 3 or more points that lie on the same line. 3 or more points that do not lie on the same line are called non-collinear points. Notation. Points A, B, and C are collinear points, while points A, B, and D are non-collinear points. Coplanar points are 3 or more points that lie on the same plane. 3 or more points that do not lie on the same plane are called non-coplanar points. Notation. Points A, B, and C are coplanar points, while points A, B, and D are non-coplanar points. Subset of a line. A line could be broken into smaller parts or subjects to better understand all its concepts and application. These include line segment and ray. A line segment is a subject of a line consisting of two endpoints and a set of all points between them. Notation: name by its two endpoints written in either order line AB or line BA. A ray is a subset of a line consisting of an endpoint and a set of all points on one side of that endpoint. Notation: name by its endpoint first and another point on the ray, ray AB. Note: the arrowhead always points to the right. It is also important to consider the following definitions. When two rays with a common endpoint extend on an opposite direction and form a straight line, these rays are called opposite rays. The term intersection refers to the point common between two or more lines. You can think of it as where the lines met. In the real world, the concept of intersection is similar to the intersection of roads and the intersection of longitude and latitude on the globe. Planes could also intersect, and their intersection is a line. Theorems and postulates. A postulate is a statement assumed to be true even without proof. It is universally acceptable and does not need confirmation of its truthfulness. A theorem is a statement that can be proven using valid methods of reasoning. Beginning postulates. For purposes of discussion, postulates and theorems will be numbered in order of appearance in this textbook. Postulate 1. The line postulate. Two distinct points determine a line. Given 2 points A and B, no other lines may be drawn containing 2 points. Postulate 2. The plane postulate. 3 non-collinear points determine a plane. As seen in the figure, there are 3 points, A, B, and C. Note that point C is not collinear with line AB. Therefore, these points determine a plane, that is, plane ABC. Postulate 3. Two straight lines intersect at exactly 1 point. Line AB and line CD intersect at point E. Postulate 4. The intersection of two planes is a line. Measuring segments. Recall that a line segment is bounded by 2 points called endpoints. Therefore, line segments are finite and measurable. In order to illustrate the concept of measuring a segment, a number line is used. In the number line, every point corresponds to a real number. This number is called the coordinate of that point. To measure the length of a line segment, simply count the number of steps of equal distance from one endpoint to the other. For example, if you want to know the length of line AM, count the number of steps, equal units, from point A to point M. Therefore, the length of line AM is equal to 13 units. Take note that the units here represent units of measurement for length. Example: Number 1. Line BF is equals to 4 units. Number 2. Line CK is equals to 8 units. This process may not be applicable if you are dealing with large numbers. In such cases, find the absolute differences of coordinates of the 2 points in any order. See Postulate 5, the ruler postulate. Postulate 5, the ruler postulate. Given 2 points A and B on a number line with coordinates A and B respectively. The length of line AB, denoted by AB, is the absolute differences of the coordinates A and B in any order. In symbols, AB is equals to the absolute value of A minus B, or AB is equals to absolute value of B minus A. Example, find the length of the following segments. Number 1, line BM. Number 2, line EK. For number 1, using the vertices m minus b is equals to 2 minus negative 9 is equals to 11. b minus m is equals to negative 9 minus 2, which is equals to absolute value of 11 or positive 11. Number 2, using the vertices k minus e is equals to 0 minus negative 6 is equals to positive 6. b minus m is equals to negative 6 minus 0 is equals to the absolute value of negative 6, which is the positive 6. Segment addition. The segment addition postulate allows you to add the measures of two shorter segments determined by three collinear points to obtain the length of the whole segment. Although it may seem trivial, especially on smaller scale or lengths, the application of the segment addition postulate on a larger scale is very important. Postulate 6. Segment addition postulate. If point X is between points A and B, then AX plus XB is equals to AB. 1. Three distinct points A, B, and C are on a line and whose segments are line AB and line BC, measures 4 and 7 units respectively. If point B is between A and C, how long is line AC? What are the coordinates of points A and C if the coordinate of point B is 8? Solution 1. Draw a figure to visualize the problem. Since the coordinate of points A and C are missing, the coordinates can be represented as A and C respectively. Solving for the length of line AC. AC is equals to AB plus BC. AC is equals to 4 plus 7 equals 11 units. Solve for the coordinate of point A. Subtract the smaller coordinate from the higher coordinate. AB equals higher coordinate minus lower coordinate. Substituting 4 equals 8 minus A. Simplifying, A equals 8 minus 4. A equals 4. Solve for the coordinate of point C. BC equals higher coordinate minus lower coordinate. Substituting, 7 equals C minus 8. Simplifying, 7 plus 8 equals C. C is equals to 15. To check, AB equals 8 minus A. 4 equals 8 minus 4. 4 is equals to 4. BC equals C minus 8. 7 equals 15 minus 8. 7 is equals to 7. I hope that you learned from our discussion, which is about the foundation of geometry.